Guys, this is page 43 of your student journal, section 2.3, special products of polynomials. Honestly, if you understood 2.2, which is multiplying, this is more of the same, except it's a shortcut. So again, if you understand what's happening fundamentally, you don't really have to worry about this shortcut. But if you do, then this will just make it easier. So let's look at these, explorers. Write the product of two binomials modeled by each rectangular array. So these, we have 1x squared. We have 2x right there. And then we have negative 2x. And then we have negative 4. But since I have a positive 2x and a negative 2x, they just cancel each other out. And then I have x squared minus 4. Okay, so there's that. That's an x plus 2 and an x minus 2. On the next example, we have a 2x minus 1 and then a 2x plus 1. So we're going to start off counting the squares. So I have 4x squared. And then I have negative 2x and I have positive 2x. Negative 1, that makes 2x. Negative 2x rather. And positive 1x makes 2x. So I have 4x squared. These cancel each other out. Then I have a negative 1. Okay, again, we haven't done too much. They already have the drawing for you, and you just have to count it, basically. So let's move on. Finding the square of a binomial. Draw the rectangular array of algebra tiles that models each product of two binomials. Write the product. So if you're a drawer, you could draw this. What this is asking is, if you're doing the drawing, it looks like this. And if you're not drawing, it looks like this. So again, if you are the drawing type and you want to use algebra tiles, be my guest. And what this is representing is x plus 2 squared, which is really just x plus 2 times x plus 2. If you're a good drawer or you're good at the tiles, then go ahead and do that. But I found that most of the class prefers just writing stuff. So x times x is x squared. X times 2 is 2x. 2 times x is 2x over here. And 2 times 2 is 4. So you end up getting x squared plus 2x plus 2x plus 4, which when we simplify, 2x plus 2x makes 4x. And that's what we get. Here, 2x minus 1, 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. That happens 2 times. Then we have negative 1 times negative 1, and that's a positive 1. So you have about 4x squared minus 4x plus 1. 4x squared minus 4x plus 1. How did I get that? 4x squared minus 2x again plus 1. So negative 2 minus 2 is negative 4. What are the patterns in the special products a plus b times a minus b, a plus b squared, and a minus b squared? This is just patterns. So if you get it, or if you don't get it, we could go back and take a look at it. So here I had the plus and minus, but then I only end up with 2 terms. Same here, a minus and a plus, that was also 2 terms. But when I had a plus squared, that was 3 terms, and if I had a minus squared, that was also 3 terms. So you should be noticing that this is double 2 times x and 2. Here it would be 2 times 2x times negative 1 to get the middle term. And the first term is just the first term squared, and the last term is the last term squared. So 2x squared is 4x squared, or 2x times 2x is 4x squared, and then negative 1 squared is 1. These are just examples. I'm going to point them out. A plus b squared, so let's just make up one. Let's say x plus 6 squared. So if I use this as my example, I will take, in this case, the a is the first term, which is x. So I will x squared plus 2ab, 2 times x times, what is b? B is the second term, times 6, plus b squared, which is the second term again. So I have x squared plus 2 times x is 2x, 2x times 6 is 12x, and 6 squared is 36. So the point of this is to show you that there is a shortcut, that if I have x plus 6 squared, I could just square the first term, I could square the last term, and then I could take each term, x and 6, and multiply it by 2 to get the middle term. And then here's another fine example, 2x minus 3. A is the first term, so this is, this example is for this formula. We have a squared, which is the first term squared, so 2x squared. We have minus 2ab, so minus 2 times a, which is the first thing, and b, which is the second thing, plus b squared, which in this case is 3 squared. And that's it. That's 2x squared is 4x squared. 2 times 2x times 3 is 12x. And then 3 squared is 9. Here, a plus b minus, or times a minus b, what could that look like? Let's say this, 2x plus 3 times 2x minus 3. So how this is going to work is that I'm going to take the first term, which this is our a, and square it. And then subtract our second term, square it as well. So I have 4x squared minus 9. That's it. Is that the last one? Yeah, that's it, guys. So if you look at these problems, and I'll walk through some of them with you, of course. If you look at these problems, you can honestly, if you don't remember the square patterns, you could just use the table or FOIL. Now, how would that look like? A plus 3 times a plus 3. You can FOIL that. You guys know how to FOIL that, or use a table or whatever. But as far as, this section is patterns. So we have a squared plus 2ab plus b squared. In this case, the a squared is a squared plus 2 times a times 3 plus 3 squared. And that's it. A lot of this is just, again, just making use of it. So, maybe, let's see, what's one more I could do? We did a plus 1, let's do a minus 1 then. We'll work on you with number 8. So this will be, a squared minus 2ab plus b squared. So I have 2a squared minus 2 times 2a times 3b plus 3b squared. 2a squared is 4a squared. 2 times 2 is 4. 4 times 3 is 12. So this is a minus 12ab plus 9b squared. Okay. Number 10, 11, and 12. These are even simpler. They're just like these ones. This example right here and this example right here. A plus b times a minus b is a squared, the first term squared, minus b squared, the second term squared. What else? All right. I really think that's it, and it's just an issue of practice. And if you don't know how to or you don't know the patterns, you don't know how to apply the patterns, then the fallback is to just use table or FOIL method. And really that's it. So if you have any questions, let me know. Otherwise, you are good to go.